Hello friends, welcome to my YouTube channel again. This is Ved here, and I'm going to cover the polars part here now. As per we know, in the last video I showed the difference between the pandas and the polars. Now here in today's class, today video, I'm going to cover that how we can implement the polars on. We will take one small data set. Actually it needed a big data set, but I'll show you it on some small data set. You can try it out by yourself on a big data set, then you can significantly find the difference between the pandas and the polars, which is very important. Now we are seeing it here, this pandas and the polars, which I have written here on the screen. Now pandas and the polars, so usually we saw in the same in the last class that how it is different, that panda is a little bit more slower, polars are faster. The pandas has more functions like APIs, too many, whatever you can think of to do the query or to solve the problem, you will definitely find the functions for that. But in polars it is a bit comparatively lesser than the pandas. You need to somehow concatenate or merge multiple functions then to solve your problem. Okay, but we can make it, but that's not the major issue. Why? Because whenever we want, we can convert polars data frame to pandas again. Okay, so let's suppose if you get trapped in a scenario where the polars doesn't have any APIs or any functions to solve that specific problem, or maybe we don't know that a specific function or API so that from polars which can solve the problem, so we can directly convert polars data frame to pandas data frame, and then we can utilize that. Now let's understand here today how pandas and the polars and the implementation of the polars. So we will directly jump to the code part. So before going to the code part, again I'm saying, to install the polars, these are the steps we need to follow. Create virtual environment. If you do not want to create the virtual environment, then try it on your base environment. So what I will do, I will give you the requirement.txt file. So requirement.txt file I will upload into GitHub, and I will give that, and that requirement.txt file you have to download it. And let us suppose you downloaded requirement.txt file is somewhere here in this location. Now what you have to do, you have to open the terminal in this location. Open terminal at this location. Now there are multiple ways to open the terminal at this location. How? Let us suppose if I'll show you, one second. Let's suppose this is my download section. Okay, now here if I want to open a terminal, I'll directly go here and write cmd and hit enter. Okay, you can see it has opened here. But now let us suppose you download it into the download folder, the requirement.txt file, and you are in some other folder like here. So what I will do, you will just open a cmd here, or you can open a terminal from anywhere. Let's suppose from your search bar, you just open the terminal here. You open the terminal here, and now you want to go to the C user with then downloads. So you can use the tab here, and it will go to the download part directly. So this is how. Let's suppose if the requirement file in your D drive, so how you can do, you have to just directly write here D and the colon, it will automatically redirect to the D drive, and then the change directory if you want to go wherever. Sorry, this is, let's suppose at this location you want to go here. See that? So like that you can do, and then let's suppose you reached our requirement file is at this location. Okay, now I want to install here. So what you have to write, you have to write pip install -r requirements.txt. That's it. You have to write it and hit enter. Since here at this file location I do not have requirement error, so it will requirement file is not available here, so it will throw error. See that, could not open requirement files, no such. But if you would have that, it will directly install. And now let's understand what exactly the things are in a requirement file. So in requirement file, actually this is a simple text file. Okay, this is a text file. This is a text file. We'll have named as requirements.txt. How we can generate that I will cover, but as of now for this installation I will share the requirement file. That is very simple. You have to simply create a text file and write, and you have to write all the libraries with their version. Let's suppose I'm writing here pandas with some specific version, numpy, polars, scipy, modin, matplotlib, like this. So you can write your all the libraries whatever it is required, and then you have to run that command wherever this location of this file is. Pip install -r and then the name of this file, requirements.txt. We have to run it and it will install all this file likely. If you are doing it in your base environment, you do not have to activate any environment, but if you have created your any virtual environment where you want to do, so you have to just go and first create the environment, and then after you have to activate the environment and then install. Now let's jump to the code part and see. So here you can see here I have imported all the files, so distributed and all those things. Now here I am running this, you can see. So it now if I want to see the version, all the dependency required for the polars, you can run this code. You can see here it is saying the polar version which I have now, so 0.19.1. Here it is saying your system OS, so it's Windows 10, and here it is Python version, it is saying 3.11.3. okay, and now these all are the dependency, required for the polars. So this one you have to install. So simply what you have to do, you have to this copy this and you have to create a one text file. Let us suppose I want to create in download, so I'll do a right click here. Where it is the new folder? One second, sorry. New folder, text file, sorry, text document, requirements. So you can see here requirements.txt. I had just opened. Now simply you have to paste it here. So these are not installed, so this is not needed. Okay, this is also not needed, and this is also not needed. And one more changes which you have to do here, on place of this column you have to write equal to. But there is a terminal command as well from which we can generate the txt file, that I will explain. Okay, I'll show, but as of now I will prepare this text file and share it with you guys, so I'm not saving this. Okay, now let's jump to the code part. So if you can see it here, we saw the dependency. Now once we saw the dependency, we have to read one file. So I'm just taking one Python file, CSV file path. Okay, and I'm running this. Now let's do this magic function. This is % time, so it will just tell you give you the time, how much it took to execute any specific code in that block. So PL, I'm using a alias name from the polars, scan CSV I'm using. This is a function of a scan CSV. There is a read CSV function in Polars as well, but we will see. This is just a first class. We are seeing it, but we will see that how it is getting difference in Polars scan CSV and the read CSV. But as of now, let's understand first file path from the scan CSV and parse date. I'm trying to parse from this data. So in pandas there is something called parse dates equal to true, but in Polars it is try parse dates equal to true. So I'm doing this, and then I'm doing it here head, and for now here I am doing collect. So why are we doing it collect? We will understand. Right now we will see the time first only. So if you can see, it has taken 16 milliseconds. Okay, so now it has taken 16 millisecond to execute that with the Polars to read that data. Now the same we need to perform it, let us suppose from pandas. So pd.read CSV, and here it is parse dates equal to true, and there is nothing like collect here. So remove this and now run this. Okay, sorry, here it is read CSV. So it has taken 11.8 milliseconds. So let's suppose here it has taken lesser time. Why? The reason behind I'm saying, we can say here, since the data set is not huge, it's a small data set. So if you would take download any of the data from the Kaggle or any of the public platform and read it through Polars or the pandas, you will see the difference. Why here it is taking lesser time, pandas is taking lesser time, since Polars is slightly a bigger library or a complex library than the pandas, so that's why their execution is taking time. But if you will go on a large data set, there you will feel the you will notice the difference, which is very, very important. But in pandas there is something called pi arrow. So by default, if you would see here in pandas, there are engine name which is called CSV engine. It will use, see this CSV engine. Now if you will use here pi arrow and then see how much time it is taking. Here this panda is from the normal CSV engine. So it has taken 81.6 milliseconds. Okay, now let's try it with the modin. We have read the modin library as well, and now let's see how much time it is taking. So the maximum time taken by the modin is 445 milliseconds. But I'll tell you how the hierarchy will be. The maximum time will always be taken from the pandas CSV, from pandas CSV using CSV engine. Then after the pandas read CSV using pi arrow. Then after modin, and the most fastest will be this. We will try to see with some complex query, and let's try to understand some complex query. And first we will understand it through the pandas. So let's suppose I'm giving a name here, a data frame name df_pd dot read underscore CSV I'm doing. Okay, and then I'm passing the file path, and let's suppose pass dates I'm doing true, and then dot group by. I'm doing a group by on okay, group by on this passenger count. Now I'll have to apply the aggregate function. Now let's suppose I want to check the fare amount. Okay, so the fare amount, and what aggregate function I want to apply? DSCRIB. You guys might have aware about this. And now let's add the magic function here. Invalid syntax. Okay, sorry. This will be the actually list. Dictionary. Sorry. Here is the dictionary. here is the dictionary. Okay, so here we can see this this one has taken 22 millisecond. Now let's perform the same on polars, and let's see how much time polars is going to take. So 22 millisecond by the pandas, and now polars. So you have to just PL scan.csv. so here I'm just changing the name df pl scan.file path. Here it is try, and then here actually the group by is depreciated, so group underscore by you have to use, and then after here this works somehow like this. Okay, so now I did aggregate. In aggregate, let's suppose I have performed something like this. Manually, if you go like this here. So let me first run this whether it is unexpected indent. Okay, let me put it here. So when we did aggregate here, after doing aggregate we have to pass a list, and how to select a column in polars, we have to use PL that alias name and then the call, and then let us suppose I want to do on the aggregation on the fair amount. So I'll select the fair amount. I will select the fair amount. Now on this fair amount, what I want to do here on this fair amount, I want to do this describe. Okay, now let's see what exactly is it not taking that? Okay, here it is taking. Okay, let's me do the mean here as well. So you can, if you would see here, with the mean value it has taken 6.6 millisecond, but when I did on passenger count and I am doing on the fair amount, the mean of that fair amount, here it has taken 4.29. so it is somehow slower, but it could be even more slower than this. We will see that how we can make it even more slower, more faster, I'm sorry, how we can make this more faster. Now let's understand when we will use the pandas with pi arrow, then how much it is going to take time. Pandas with pi arrow. So simply we need to use this pandas with pi arrow. So for the pi arrow again, here just simply we have to use engine is equals to pi arrow. Let's see. So this pi arrow has taken here 7.5 millisecond. Now let us understand how the very basics now will start. So this is that for the time I just explained. Now let's understand the data types in pandas. So this is a Titanic file. I'm just trying to read, nothing else. So now I'm reading it through the polars. Okay, that's how polars will be. So it took, for to read this file, it took 17.1 millisecond. Okay, Now if you want to see the head of that, it is simply you can just use this. You can see here, this is the head of that data frame. Okay, now and if you want to check the data type for this data frame, you will see this will be polars data frame. Okay, this is a polar. Now if I want to check the data type of each column, if I want to check, you have to run it like this, DataFrame.schema. So it will create a dictionary and with the column names and their data type. Okay, now so wherever you will see this str, it will write actually UTF, the encoding part it is writing UTF-8. Okay, so you can understand it like this, but here it is writing clearly this it is. But the D types is also available here in polars as per the pandas, but this is not more that's not better for the polars. You can see it will only tell. Now you have to again print the column names and everything, and then you will get that. Okay, and the D types for the single column, if you need that you can also do, like here for the name column, if you do the D type, it will tell it's UTF-8. Now the one thing which is very important and we must have to know about the Apache Arrow, the engine which we use. So what exactly those Apache arrows are? So Apache Arrow it is of open source. Okay, open source language. So these are built to represent the tabular data in best way in your memory, that how it can fit in the best way. Okay, so the polars also use this Apache Arrow. Now the reason is why actually they use polars, they use because they have the something a terminology called zero copy. Zero copy, as in we will see it from the code as well. Whenever we try to create something or to copy something, so zero copy means it will not keep on creating the copies to make your memory full from the data. If it will be same, it is not going to make the multiple copies for the same. Okay, and it is faster vectorized calculation, more faster than the pandas, too much faster than, we will see it in later. Okay, but this polars has their on Apache Arrow, they have their own UI way to show it, but we can see the Apache Arrow from the polars as well. If this is the polars data frame, okay, this is the polar data frame. If you want to see, so you just simply you have to write 2_ROW, 2 arrow. So if you do this 2 arrow, see this here, or your column name, these are the column name. Okay, embarked here is saying that it's a large string. Okay, all your column name here, and this is a column name with some values it has printed. So this is passenger ID with their some value, survived with their value. Like here you can see this dot means there are multiple, not many values are there as per it is printed in the pandas data frame. Okay, simply if we want to just perform this to do head and all, it is as simple as this. I think by default it will print 10 5 1 2 3 4 5 it will print. And simply if you want to do a single data, so you can use, so this is square bracket. Actually this is not a good way to use in a polars, but currently I just want you guys to make comfortable with the polars. Okay, and then we will see the exact functionality how we can use to optimize it in more better way. Okay, so this is but this is not a correct way, actually the optimized way to use, not correct or not the optimized way. Okay, this is the another way we can use, like if I will just copy it here, dot select age. Let's suppose I'm selecting this column, and now if I want to convert to series, and then I'm just using this head, six values are see that. So here it is series, you can see it's a 1D series, there's no column, it is coming the way it is, and here also same. Now again, if we want to convert this into a data frame, okay, so you can see the shape here 6 and there is a no column. Now if I want to convert this into a, so here in spite of this, stick this to here, and in spite of going with series, there is something called DataFrame. Okay, sorry, in select it is not like this, we have to do. See that now it is 6 by 1, you can see. The question is it possible that we can create it from the list of the values from the then polar data frame? Yes, we can do that. We can do that if suppose this is the value, and then if I want to do pl dot, same like in pandas, pl dot series, then data, you can do that. There is a way, if by default it has not given any column name, if you want to just give the column name, I wrote here col1, and then here this comma. Now see, it has given this column 1. So in systematically we will do it. I'm just making you guys comfortable. If you want to convert this into a list, you can just simply use toList. Series, sorry, to underscore list. You can see it's converted. You can use the multi-dimension list like that also, like 10, 20, 30, and then other is 100, 200, 300. Okay, now pl dot data frame, you see it is there, and then I will pass data. You can see by default column 0, 1, and if you want to give the column names again, you have to simply pass here the schema, nothing else. Schema you will pass in a list, and it will take that schema, and schema in a list. Let's suppose here I want to write like column 1, column 2, correct. See that by default this was, but if you want to give any specific name, you can write it like this. We can do this from the dictionary as well. From the dictionary also we can. Let's suppose I am creating this data and here I'm writing col_1, this is column 1, okay, and this is a some value, so I'm repeating this value. Let's suppose increase it by 1 so that it looks some different, and then after col_2, okay. Now simply if you want to do pl dot data frame and then dict data. So when I did here dict data, and this key values have become the columns. Okay, we can even do that. What I can say, we can pass the schema to make sure they are data type as well. Schema is equals to, in a dictionary I want the call 1 to be pl dot, let's suppose, int 64, and what I want, call underscore 2 float, sorry, pl dot float 64. Okay, now run this. You can see this one is in float, this one earlier it was both was in integer. Okay, so this is how you can do. And if you want to convert into a dictionary, again you can just simply do 2 or dicts 2 dicts. See that this is the first value, like column, in column 1 10, column 2 100, column 1 20, column 2, so like this it will give the value. Okay, if you want to check, you can check it as well. Now if we have this data frame already, Polar's data frame, if you want to convert this into numpy array, np array dot 2 underscore numpy, numpy we can do dot 2 underscore numpy and np underscore arr, you can print. See this is simply a numpy array, it has printed, you can do that. Now let us suppose the way in a pandas, like if you want to select on some specific data type columns, like integer column, like float column, or like object column, like in pandas there was something called DataFrame.select d types. The same way here also, like this is our DataFrame dot select, and in that select what I will do, pl dot column. In pl dot column what I want pl dot float, whichever the float data frame, I mean the float data type, those columns I want. I'm simply doing okay, let's not do this here. See, so these are the float, you can see it here. Let's do the head. You can see this is the head for the float. So this is how you can do it for the, and there is something called a function called glimpse. So glimpse will give you the some data frame values with their integer, you can see. Row 89 column 12. Sorry. So this is how it works. Now what that zero copy part which I explained to you, so we can see this is the way we can see the glimpses, some column name with the value of that column. Now let's understand what exactly that zero copy part was and how it works. So here I am creating a numpy array dot, like I'm creating some value with dimension, let's suppose 20 by 8, 20 by 9. Okay, and just if you want to see in the data frame, this is column 0 to column 8, 9 columns are there. Now let us suppose what I want to do. So the one rule for the zero copy method, only we can create for those column or for those data in which there is a no null values. if there is a no any null value. Okay, and now let us suppose here I'm doing 0 array, I'm doing, and then I am taking this frame and I'm taking the age column. Okay, dot head I'm taking that not to go with the complete, and then I'm doing here 2 numpy, and here we need to pass this 0 copy only is equals to true. Now let's see this, the values. Okay, it has the null value age has the null value, so let me select other fair, let me select. That's why I said that if there is a null you cannot create. Yeah. Here it is generating the 10. See here, when we are doing it for the by default is 10 values. 10 values. So that's why we just convert. Now what is the difference? Let us suppose now at this, in this array at index 3 I want to update the fair by 777. So you can see what it has said. It is read only, you cannot do, but let me try it without 0 copy and then try to update whether it is equal to or not. By default it is taking 1 second. By default it is taking here 0 copy only, this polar. So I think we need to make it explicitly false. Why it is not okay on this? We'll see that, but probably it should not do. We'll see that how exactly it works. And then after the same way we can convert this to pandas, to pandas here, and there also there is something called use by arrow extension equals array, and then if we'll make it to true, so what it will do, here we are creating pandas data frame without copying the data, and then we know once we have a pandas data frame we will have a lot many functions for this. So this one will be similarly completely look like a pandas data frame, as we are aware of that. So this is how your polar. So now tomorrow in the next video we will start indexing, how it perform, slicing and indexing, slicing, and then after filtering those from the basics and from completely from the basics we will completely start, and we'll try to understand it from the scratch, that how we can perform it. And here one more thing, if we want to see the data type, actually it's a pi arrow or data frame, so the data type will somehow look like this. See this, these all are the pi arrow. We had seen it above as well when we did 2 arrow same way, but here all the pandas functions will work on this, almost 95% of the functions. So these three parts we will see it tomorrow, that what exactly the indexing and slicing, those all are okay, and try to understand this filtering. So the requirement file and this all, I will add that into the GitHub and share the link. Okay, so till then, keep learning. Thank you so much everyone.